Hi friends, today I will solve another CSIR Net 2023 problem. The problem is like this. You have been given two operators A and B which satisfy the commutation relations HA is equal to minus H cut omega B and HB is equal to H cut omega A, where omega is a constant and H is Hamiltonian of the system. You have been given the expectation value of A in state psi at time t equal to bra psi A ket psi, such that at time t equal to 0, expectation value of A in state psi at time t equal to 0 and expectation value of B in state psi at time t equal to 0 is equal to I. So you have to calculate the expectation value of A in state psi at time t equal to 2t. So this problem is a little bit tricky one, but we'll solve and we'll proceed for the solution. We have to use our brain little bit. So let us proceed for the solution. In this problem, we have two operators are given, that is A and B. So we will apply Ehrenfest theorem on operator A and on operator B. So we will apply from Ehrenfest theorem. We can write dA upon dt is equal to AH plus del A upon del T. So in the next step, dA upon dt is equal to, if we will see in our problem, then we have HA is equal to minus H cut omega B. Then AH will become H cut omega B. Then we have here we have 1 upon I H cut also. Then we have 1 upon I H cut. We have H cut omega B plus 0. Then we have dA upon dt is equal to omega upon I into P. Let it be equation 1. Similarly, for operator B, we can write dB upon dt is equal to, we have 1 upon I H cut BH plus del B upon del T. And if we will see in our problem, then HB equal to H cut omega A, then BH will become minus H cut omega A. We have dB upon dt is equal to 1 upon I H cut. We have minus H cut omega into A, then and del B upon del T will become 0. So and partial derivative of B with respect to T will become 0. Then in the next step, we are left with minus omega upon I into A. So this is our second equation. In the next step, we will take another derivative of A with respect to T for equation 1. So here in the next step, T2A upon dt square is equal to, we have omega upon I into dB upon dt. Then d2a upon dt square is equal to omega upon I, and dB upon dt is minus omega upon I into a. Then minus omega upon I into a. Then this I and this I will become minus 1, and minus minus will get cancelled. Then we are left with minus, we are left with plus omega square into a. The next step, we have our equation d2a upon dt square is equal to omega square into a. Let it be equation 3. And we all are aware the solution of this differential equation we have solved in our mathematical physics. So the solution of this differential equation is C1 e to the power omega t plus C2 e to the power minus omega t. So in the given problem, you have been given the expectation value of a in state psi at time t equal to 0. We will use this condition in our result. So we have C1 plus C2 is equal to 0. Then let it be equation 4. And we will, in the next step, we will take the derivative of this with respect to time. Then dA upon dt is equal to C1 omega e to the power omega t minus C2 omega e to the power minus omega t. Then, and in our previous result, if you will see, we have dA upon dt equal to omega I into b. We will use this equation 1 in our equation. So we have dA upon dt. So we have C1 omega e to the power omega t minus C2 omega e to the power minus omega t equal to omega upon I into b, operator b. So in the next step, we have C1, we have our equation C1 omega e to the power omega t minus C2 omega e to the power minus omega t is equal to omega upon I into b. We have here, we have to find the values of C1 and C2. So here we will put t equal to 0 in this equation. So our equation will become C1 omega minus C2 omega is equal to, we have here we will put t equal to 0, and in our problem, if you will see, we have b at t equal to 0 is I. So we have omega upon I into I. So we will get C1 minus C2 is equal to 1. Let it be equation 5. Earlier we had C1 plus C2 is equal to 0. From these two equations, we will get C1 is equal to half and C2 is equal to minus half. We will put the values of C1 and C2 in our equation number, in this equation. So here In the next step, A is equal to omega t minus e to the power minus omega t by 2 here is equal to sine hyperbolic omega t. So we have got the expectation value of A in state psi at time t equal to sine hyperbolic omega t. So this is our correct answer. If we will see in our problem, then option 2 is the correct answer. And if you will again see my solution, then here I will again explain once more. Here I have used Ehrenfest theorem for operator A and operator B. I have got this result in equation 1, and again I have used Ehrenfest theorem for operator B, and again I have taken the second derivative of A with respect to t, and again in the next step I have got the expectation value of A at time t in state psi, this, and after I have played a trick. I have calculated the value of C1 and C2. I have substituted the values of C1 and C2 in our equation, and I have in the end I have got the result as sine hyperbolic omega t. So this is from my side of solution. If you like my problem solving technique, then please like, share and subscribe my YouTube channel. That's all. Thank you.